All right, so today in class we talked about section 6.2. I'm just going to go over a few more examples. Just a reminder, substitution is when you plug something in for something else, when a variable in this case is set by itself. In other words, like x equals or y equals. In this first example, notice y is by itself and it says it equals negative 4x plus 11. So therefore, we can plug in negative 4x plus 11 in for y. So when I do that, I'm going to have 3x plus negative 4x plus 11 equal to 9. Okay. Normally, there's a number in front of where you plug in. In this case, there isn't one, so we just assume it's 1. So I can distribute that 1. And when I do that, I still have 3x minus 4x plus 11 equals 9. So I combine my like terms, which would be the 3x and the negative 4x, and I have negative x plus 11 equals 9. So I'm going to subtract my 11. I get negative x equals negative 2, so I'm going to divide by negative 1 or get rid of my x here, so x is going to equal positive 2. Once I have that, then I'm going to take my 2 and I'm going to plug it back in for x. So I have y equals negative 4 times 2 plus 11, which is negative 8 plus 11, so y equals 3. So my answer here is going to be 2, 3. And again, if you want to check it, you can check it two ways. You can graph both of these equations and see where they cross, and that point should be 2, 3. Or you can plug this back in for your original equations. If I plug 2 in for x, obviously in the first one I already know negative 4 times 2 plus 11 equals 3. But then I can also check the second one, 3 times 2 plus 3, that does equal 9. So I know that's good, so I know that is my final answer. For the next one, you talked about it earlier. This one kind of they look pretty similar. If you multiply the top one by 2, you kind of get pretty close to the second equation. But in any case, we still want to use substitution to solve this out, just to check to see maybe it's a no solution or an infinite solution. And in this case, the top one's pretty easy to solve for. If I have 3x plus y equal to negative 5, I can solve for y by subtracting 3x over. So I have y equals negative 3x minus 5. So I'm going to take that and I'm going to plug it in. So 6x plus 2 times negative 3x minus 5 equals 10. From there, here's where I'm going to distribute. So I have 6x minus 6x minus 10 equals 10. Well, 6x and negative 6x cancel each other out. So I have negative 10 equals 10, which it doesn't equal 10. So therefore, my answer is going to be no solution. Here's another problem that looks about like the previous one, because they're both 2x plus y. The second one's obviously negative 2x plus y. So, again, you can think maybe it's no solution, maybe it's infinite solution. But again, let's use substitution to solve it out. So again, I'm just going to use the top one, 2x plus y equals 4. I'm going to get y by itself, so I'm going to subtract 2x. So I have y equals negative 2x plus 4. So I'm going to take this, plug it into the second one. So negative 2x plus negative 2x plus 4 equals negative 4. Again, I have 1, so I'm just going to basically get rid of the parentheses. So negative 2x plus negative 2x plus 4 equals negative 4. I have negative 4x plus 4 equals negative 4. So I subtract 4. I have negative 4x equals negative 8. So I divide that out and I get x equals 2. Great. So I can plug that 2 back in here. So y equals -2 times -2 plus 4, -4 plus 4, y equals 0. And you might say, well, how can y equal 0? Well, that would just mean that where these two lines cross would be on the x-axis. So that answer is perfectly fine where you have 2, 0 as your final answer. And again, you can plug that back in to check and make sure it works.